Today we are going to study about inductance, and it is the property of an inductor, and inductance is given by a symbol L. Now, inductance means how much opposition to current a particular circuit has. Now, let's try to understand it with an example. Now, let us say that there is a circuit which has a battery and a resistor, okay, and there is a switch S. Now, when this switch is open, initially it is open, and then you close the switch. As the switch will close, the current will start to flow through the circuit. So it means that initially when the switch was open, current was 0, but now the current will increase because it is a closed circuit and there is a battery and there is a resistor, so current can flow in this circuit. Now, when current starts to increase in this circuit, then as you all know that magnetic field, current will give rise to a magnetic field. So it means that if the current will give rise to magnetic field, and this magnetic field will also increase. But where is this magnetic field that we are talking about? So now, because the positive terminal of the battery is in this side and negative is in this side, the current will flow anti-clockwise. Okay, so in this wire, it will create a magnetic field which will be along the wire, and the magnetic field will be around the curled fingers. So if we take only this wire, and due to this wire, the current will be crosses this side and dots this side. Okay, and then let's say now we can take this wire, this one. So for this one, the magnetic field will be crosses this side and dots this side. So it means that the magnetic field inside this circuit, this is the magnetic field we are talking about, which is created due to the current which is flowing in this circuit. So as the current will increase, the magnetic field will also increase. So now, because you know that the magnetic flux is given by BA cosine of theta, so now we're talking about this area, and we're talking about the magnetic field which is pointing upwards. So it means that the area vector is pointing upwards, and the magnetic field vector is also pointing upwards. So it will be B into A cosine of 0. So it means that the magnetic flux will be equal to BA, and if the magnetic field will increase, the flux will also increase, or it means that the flux will change because the magnetic field is changing. Now you know that if there is a change in flux, an EMF is generated, which is nothing but Faraday's law. Okay. Now Faraday's law says that an EMF will be generated if there is a change in flux, and with multiplication n. Okay, so this means that if there is a change in flux, this whole, it means change in flux, magnetic flux. Okay, change in flux gives rise to EMF, or a change in potential, okay, such that it will act opposite to the change. Okay, so in our case, because the flux is increasing, so an EMF will be created which will try to oppose this current, this change in magnetic field and change in current. So it means that this EMF will try to oppose this current, and it will try to induce a current in the opposite direction. The current is in this direction, but it will try to oppose this current. And this opposition to current in a circuit is called induced EMF or self-induced EMF. So due to this current, which is in the opposite direction, the current will increase, but the increase will be a very slow increase, because it will have an opposition to change. It will not want it to change. Okay. So this opposition to current opposition to change in current is called inductance. Okay. So in a circuit, how much capacity a circuit has to oppose a current, how much opposition it has to current, is called inductance. Now this particular case is called self-inductance. Why? Because induced current opposes the current which produces it. Okay, so this current gives rise to a magnetic field, and that magnetic field gives rise to an EMF, and that EMF creates a current which opposes I. So if I have to summarize this, what it means is that I gives rise to a magnetic field, and because it is changing, so we say that suppose if it is increasing, magnetic field will also increase, and this gives rise to a change in the magnetic flux, and this gives rise to an EMF, and this EMF will give rise to another current I dash, and these two currents, they will oppose each other. Okay, so because this has been created by this current, so that is why we call it as self-inductance. The induced current opposes the current which has induced this current. Okay, this is called inductance. Now in a circuit, inductance is usually, we don't talk about the inductance of a circuit, we talk about the inductance when we have a solenoid in a circuit, we say it is an inductor. So why do we say it as an inductor? Because now if let's say that the current that is flowing in this circuit is I, so let's say time is equal to 0, there is no current, but as time will increase, the current will start to increase. Initially there is no current, but after some time the current starts to flow. Let's say there is some switch somewhere and we close the switch and the current starts to flow. Now when the current starts to flow, this is a solenoid. Okay, and in a solenoid, there is a magnetic field in a solenoid which is given by mu naught Ni. So the magnetic field inside a solenoid, it depends upon the current. So if the current will increase, the magnetic field will increase. Now this magnetic field, it is the magnetic field in solenoid. So if it will increase, it will give rise to an EMF, which will give rise to a current which will try to oppose this current, oppose the change. So it means that it will induce a current in the opposite direction. It will try to oppose this change, or it will act like a battery which can also be drawn like this. so that the current flows from positive to negative. Now in this circuit we have two magnetic fields. One is the magnetic field inside the solenoid, okay, and the other magnetic field is from the circuit, okay. But this magnetic field, let's say it is B1, and the magnetic field inside the solenoid, let's say it's B2, it is very less than B2. So when we're talking about a circuit with a solenoid, we'll talk about only B2, only the magnetic field of the solenoid, and we'll not talk about this magnetic field in a circuit. So if there is a solenoid in a circuit, it is called an inductor. So what is an inductor? Inductor means whenever we use a solenoid in a circuit, that is called an inductor. And inductor has a property which is called inductance. Okay, and it is given by L.